Good morning, everybody. It's Ted here. Today, let's see, we just started this new series on how to prototype games kind of quickly, starting on a Mac. Sorry if you've got a PC. I think Casey Muratori's Handmade Hero is probably better for that. Today's day two, and what we're going to do is start to put together the build process for the game, start to kind of do the boring kind of project management stuff, getting set up on source control, that kind of stuff. So a lot of this may be pretty familiar to quite a few of you. So if that is the case, if you've kind of already got a game and you've got a build process set up and you've sort of done that, then I guess I don't really know what to tell you. I've already got a video on that, and what I'm trying to do with this series is make it so that somebody starting from day one could just kind of like follow all the way through until they've got, the start of a game prototype. And what I imagine is quite a few people will kind of follow along and they'll get to a point where they feel comfortable making their own thing without my assistance. And then they'll just get off the train and go do that. And so for those people, like, I completely encourage that. That's actually what I did with Handmade Hero. I just kind of watched it to a point, and then I was like, okay, I think I got most of what I think I understand most of what I need to understand here to get going. And then I sort of like hopped off the train and went and did my own thing. So that might be you. In any case, if you have never dealt with doing a build on the Mac, this is what this is about. Day two. So this kind of assumes that you've already got your project started and set up. So right now I'm actually inside of the project directory. If I press colon and then R and then exclamation point ls, you'll see there's nothing there. And then if I also do the netrw directory on my video tutorial, you can see that we don't have anything. So this is where the directory lives on this computer. We don't actually have anything in this folder, right? So now what we need to start doing is building out a little bit of that infrastructure, just kind of the basic build process. So the way I like to do it is I like to have a build directory that is separate from the actual source code directory. And there's a lot of good reasons for that. This is yet another thing that Casey covers in Handmade Hero, but the idea is we don't want the result of the build to kind of get mixed in with the code. It gets to be pretty messy. If you have been doing, say, iOS development or like iPhone development on the Mac using Apple's kits, their default build setup that you would use, like from Xcode, if you were to just start an Xcode project and kind of follow along with that, that process basically does have a build directory. It's just that Xcode manages all of that for you. And in my humble opinion, I'm of the view that Xcode's build process is pretty darn, I would say it's pretty complicated. And I think it's just because it sort of buys into this philosophy of like only building the parts of the code base that changed. And that can be fine. That can make things a lot faster, but it also can just create this kind of nasty problem. It used to be a lot worse. Actually, nowadays it's not so bad, where sometimes you wonder why your project won't build or whatever, and then you find out, oh crap, I need to clean the derived data, I need to like flush everything, I need to do all these other things. What I've actually found is that with those more complicated kind of default build processes that come with Xcode, it's like supposed to make the build process like more abstract and like out of your way, but actually I find myself getting kind of like more involved in the build process in kind of an annoying sort of a way. And what I found in my own projects is I actually, again, I think I do agree with Casey here as well. I like to just build the whole thing every time. I don't like to have conditional kind of build dependencies or like build only what changed. I think that requires a lot of kind of complicated management of, looking at different files. It's just a more complex system. Now, if you wanted to do a build where, say, there's certain parts of it you don't want to build over and over again, or certain things that kind of do take a lot of time you don't want to do, I think there's some other ways that we can kind of get around that don't necessarily involve adding a ton of complexity. So we'll look at some of that. But basically what we're actually going to do when we build this game is we're going to manage our own build directory, and we're actually going to build everything, 100%, the whole app from scratch every time we run the build. And what I find is that most of the time this does not take that long. It takes like 5 or 10 seconds. So I compare that to probably the worst offender. Well, just a regular iPhone app I think actually takes longer than that because their build system is so complicated. But the worst offender obviously being React Native, which probably takes like 30 minutes to build the thing. It's got so many dependencies. So we're just like not going to do that. We're just going to like go our own way. We're going to say, screw that, don't like it. What that means is we're going to make a directory, and we're going to make that our build directory. So I'm going to just hit, I'm in this netrw directory listing. I'm just going to hit D. What lowercase d does is it says, okay, we'll create a directory, and we're just going to call this build, right? So you can see that immediately reflected in the navigation. We've got our build directory. And if I hover over it and I hit enter, and I go into it, and then I hit D again, we'll just call this Mac OS, okay? So what I like to do is I like to have a build directory, and inside of this build directory, there's just a lot of other, it's going to output the build for a lot of platforms. So this later on, in a more kind of robust project, if we look at, say, some of my other projects, like, let's look at, this would be Moose Solutions. That's the game I'm currently working on. Let's look at like the build for that. So there's a Mac directory and a WebAssembly directory, right? Because those are the two platforms that supports. The more platforms, the more kind of output, build directories you have. But since we're starting on Mac, we're just going to have build/Mac OS. And then in build/Mac OS up here, this is where all of our stuff is going to end up, basically. That's the idea, is the build directory is going to contain the executables, a number of other different things that are useful for debugging. So we're gonna do that. And then what we want to do is, right now, just because we're starting with a Mac platform, Casey calls this a platform layer. I think that's a good way of talking about it. Basically, what we're going to do is we're going to make a directory for the platform-specific code that is only really going to run on a Mac. So to do that, we hit D, and then what I like to do is I just like to call it Mac. Actually, wait, I like to, so let's go build, and then another directory would be for code. And then inside the code directory, we can have the different platforms. First thing I'll do, though, is just kind of create like a little stub for the game library. So I like to do game library. So that's one directory. So remember, this is this idea that the game is kind of like a little cartridge, right? Or that it's off in its own thing. There's cross-platform logic that's in this game library, and all that our game does, all that the platform layer does, is it like talks to that game library. So, and it's going to ask it things like, hey, I need some sound, or I need some like vertex buffer data, or I need you to load me the textures. So that's kind of what that does. We're gonna hit D again. We're gonna create another directory, and this will be for the Mac platform layer. So let's call it Mac platform. Okay. And now inside this Mac platform directory, we're gonna have, we are going to have all of the stuff, not only the code for the Mac platform, but also the code that builds the executable. So this includes the build system for the Mac platform. And so the very first file that you want to create, I usually just prefer to start with like one source file, right? And not overcomplicate it. And then maybe like as we kind of get going, we start to move things into different folders. So we're just going to start with like a really simple source file. And that's to make, by the way, if you're on this netrw kind of terminal thing like what I'm using, to make a new file, you hit %. And so I would call this Mac OS name.mm. And the .mm extension is just what that is it's saying inside of this file, we are going to have a little bit of, we're going to have a mixture of Objective-C code and C++. So that's basically what that is. So it allows our compiler to compile the source code with both those kinds of code in there. So in this case, I think there's actually fairly little that we need to do just to get something building. I'm not really sure I remember the default. I think it is. Let's actually look that up. So I'm gonna look that up just from like another. I can do some of this stuff completely, without any help. But if I look at like my other New Solutions code here, main, yeah, it's just this. Okay. So what this is it's just a function. It's just the entry point. Yeah. So just code entry point, whatever. So basically, like when this is where the program really starts. Now, if you've done other kinds of Apple programming, a lot of projects kind of by default hide this from you, right? So if I was to create, say, let's say that I went into Xcode, and this is kind of what you get in a lot of like these Xcode tutorials, which, a lot of like what I'm trying to fight here is that like most Mac tutorials don't actually go into the meat of much of what's actually done here. And they just sort of like, it's like, oh, let's use the template. Okay, well, that's fine, but does that really teach us about what's going on here? So I'm just showing this to you as an example. Let's say that I did create a Mac OS app using one of the templates. What I'm trying to show you is that if you were to do one of these apps using Xcode, then it would set up a bunch of stuff for you. And one of the things that it would set up for you is this entry point into that main function. So if I was to click on app and then go next, and then so I'm just going to call this default Mac app, right? This is just like, or like template Mac app, something like that. So if I made one of these template Mac apps, and then I use, okay, so like a lot of this stuff is not super useful. Of course, they want you to, I don't want Swift. What? Oh, okay. Wait, well, I want this. What? Okay. Previous. Well, this is interesting. I guess I wasn't expecting that the default thing for any kind of a Mac app would just be Swift UI. Wow. Huh. They must really, really not like storyboard. Okay, I guess if I do an iPhone app, and oh, that's weird. I'm just, like I said, I'm just showing you. So default iOS app. iOS and macOS are actually not all that different from one another. So you'll see. But yeah, I guess that's kind of what I have to do if I want to. I guess they're really pushing Swift UI, huh? anyway, if I want to do it old school with Objective-C, and I do the iOS app, right? And then, I don't know, I'm just going to throw this in like my experiments directory or something. I don't know. I just want to show you, that's all. All right, so then this is going to take longer than it needs to take in order to actually like create my project because, I don't know, people don't know how to write code. So, all right, you'll see that this gets created, right? And so this thing here, this basically is a part of kind of any kind of Objective-C app. So this entry point is there. It's just that people are very strongly encouraged not to do anything inside of that function. Now, does it actually matter whether you do stuff inside of the main function or not? I can tell you from 2 years of experience of building a video game natively on the Mac that you can use the main function, right? Like there's stuff that you can do. The important thing though is at the end of this, you have to return. You have to do this UI. You have to call into this thing here. There's a number of different reasons for that. Basically, what I've discovered on Mac apps is that trying to manage your run loop yourself and trying to time it properly for video games is just kind of a non-starter. There's a lot of things that don't end up not working all that well. So if you want to kind of get better, much better CPU performance, GPU performance, all that stuff, you pretty much have to use this. So we are going to use this last line here in a default project that Apple would set up for us. But I don't do any of this stuff like the app delegate class name. This to me is just like boilerplate code. A lot of what people are taught is that this app delegate thing is, and we'll talk about some of the object-oriented stuff. Basically, like I want to teach you enough object-oriented stuff to kind of know what it is and to respect what it is, but not to actually like drink the Kool-Aid. So this is a lot of that. But basically, like what you usually would be taught is that you shouldn't ever put any setup code inside of this main.m. It turns out that's not actually true. You can basically, use this main function as much as you want. It's totally fine for setting stuff up. There's really no problem doing that. I do it. But yeah, you're supposed to wait for application did finish launching, or you're supposed to wait for this particular event to call. Potato. I haven't found this to be all that useful, at least for what I do, which is mostly prototyping video games. So that kind of is the common wisdom, but there is actually a point where there are some things that interact with the operating system where if you don't use this application did finish launching with options thing, what I found is that some of those things don't work. So, but it's more like operating specific things, operating system specific. It's not specific to your project. So we definitely need that. And actually, what I'm going to do is I'm going to get we'll copy this, but we're not going to use it. So how about that? We'll just copy it because we know we need it. Okay, and I'm just going to comment that out. And then another thing too that so right now you see that in this Vim window or NeoVim window, all my text is like not colored fancily. I believe one of the things that you need to do in order to get it nice and fancy is you need to go, so hit colon, and then type set file type equal objcpp. Okay. Now you can start to see that it actually has some color to it. So objcpp, basically what that is it's I think it's some fancy term that Apple gave to it. It's called Objective-C++, which is, as I said earlier, this file later on, I'll show you kind of a more fully fleshed out version of this thing for one of my other projects. This file later on is going to have a bunch of stuff in it. It's going to have some Objective-C in it, and it's going to mix Objective-C with C++. So that's kind of why it's called Objective-C++. It's sort of like working with both of those languages. That's kind of what that is. So, and then what I want to do is I want to just like have a little print. Let's use Apple's NSLog. So I think if we just do import foundation, I actually never remember my foundation or my I never remember my imports on Macs because I don't deal too much with the actual operating system code. So what is it? Foundation. If we use AppKit, then that'll be fine. So we're just going to import AppKit, and what that means is that we also have to later on, we have to build this framework, or we have to include this framework in the build process in order for it to work. And we'll just do NSLog. You may be used to this. New solutions is running. Okay, so that's just yeah, that's just saying, okay, we're running new solutions. So this is our main entry point. And now if we don't do anything here at all, basically if we run this, the app is going to open up and it's going to quit right away. Why? Because actually no, at the very end we have to tell it to return 0, right? So what we're saying is exit out right away, and don't return like an error code or anything like that. So what this is going to do is it's going to print something to the console saying Moose Solutions is running, and then it's going to return, it's going to leave. So that's all that is. That's nothing like fancy. And we're not actually setting it up so that I can like keep a window going or doing any of that other stuff, right? So this is like bare bones. So in the same file or in the same area, I'm going to then, one of the things you can also do in this netrw editor is you can open like a vertical panel, which is kind of nice to use. And so I do it all the time. I hit :VEX, and then what that does, you see, is now I'm actually inside of my directory here where I've got this file. And remember that we're going to also put the build script for this game inside of this file, right? So, or inside of this folder. So I'm going to actually just create that file. I'm going to use %, and it's build.sh, right? So build.sh, what that does is it's a script that we're going to run inside of this folder, and that's the build script, right? So just to get kind of the most bare bones, first thing I like to do is just say echo, building, just the name of the game, Moose Solutions, okay? So that's what this is. We get that going, and then the next thing, let's just build so I can show you kind of the result of what happens if you build it to the same directory where it is. And actually, I don't really remember the exact invocation of Clang that we want to do, but I do know that it's Clang something. I know it's Clang-G. Probably, so then I think it's the file name. So another thing that you can do in this, actually what I'll do is, so what I did is I just held down Control and then I hit W twice, and now I'm quitting out of the other window, and then I'm going to open up another window that's got my file in it. So now I just yanked it here. And I forget the exact order here, but it may be, I don't know, I'm kind of guessing. New solutions. Okay, so I'm not sure if this will actually work or not, but we'll find out pretty soon. So This -G flag, what that is it's a compiler flag saying also when you build this, generate the debug symbols. So what that's going to do is it's going to generate the dsym file, which is used to debug it. We're not going to be doing debugging right away, but pretty soon, actually, we will get set up with an Xcode project that does allow us to debug our executable. It's a little bit finicky, but it does work pretty well, I think, most of the time. Sometimes it doesn't, though, and that's confusing and annoying. But we'll do what we can. So we're actually gonna try and run this. It's probably wrong because I don't remember how to do it, but we'll see. So right now, if I'm back in my Scratch directory and I go rls, now I can go cd code/Mac platform, right? And now if I do r!ls, you can see that we're currently inside of the Mac platform directory. And now what I'm going to do is I'm going to use that r exclamation point, and then I'm going to run the build script. And what that's going to do is it's going to take the result of the build script and it's going to read it into my little Scratch pad buffer area, so that I can just see it and manipulate the text. So I can do r!sh build.sh. And it's probably wrong. Okay, so this already, so you can see a few things here in my output. First thing is, okay, building new solutions. All right, clang error, no such file or directory, new solutions. That's a clue. What that clue tells us is we must have told it to build this thing, new solutions, the word new solutions, as if that's the file. So what I'm guessing is we just like messed up the order here, and we should have done this instead, right? So we should have gone clang-g new solutions macOS main.mm. So let's see what happens with that and see if that gives us what we want. What? No such file or directory in the solutions. Alrighty. Well, that's interesting. New solutions. Maybe it's /new solution. Sometimes you actually have to tell it. Hang on. My spouse is telling me that I actually, just before this, I went into the attic and disposed of a rat, so that's what that's all about. All right, well, that sucks. I don't want to spend a ton of time going over this, so I just want to find, like, I'll just go get another build script that I know works. A lot of this is like, so much of this is like, oh, you got one thing working and then you just use it for the next thing. So clang, okay. This is like, I'm just grabbing from my other stuff. All right. Ugh, so much to do here. Okay, so I think what oh no, wait, this is the -G. Okay, this is the platform layer. All right, I think it's just like the matter of the different, yeah, the different -O new solution. I think I just didn't get the O. So I think without the, I forget what the O flag actually is. Hang on, let's look that up, just so I'm not like a total idiot. -O flag, let's see what that is. I forget what that is. Diagnostic Flags. You can get into a total rabbit hole just like reading all of these things. So it can take kind of a lot, like, this is just, but I forget what -O does. I don't actually know. I don't want to spend a ton of time in this, like, documentation hellhole. Languages. Yeah, I mean, a lot of this is like, you've just played around with it a lot, and you kind of like, software is so complicated. Introduction. I don't want these diagnostic. We'll get into the diagnostic flags later. Oh, this is all that. What if we just search for like clang-o? I know it's like okay, I know that I need the -o. I just don't actually know what it does. Wow. Okay. If somebody has a comment, maybe it means make object files, make the OBJ files. I guess that could be what it is. Not sure. Could mean make an executable. Find out. Hey, that seemed to do something better. Okay, great. So this actually did. So the putting the -o there was important. I think what that meant is like, I don't know. I'm annoyed that I don't actually know what that is. What does -o mean in compilers? Compiler option, -o. All right, well, you know, again, it's like one of those things where if your goal is to prototype a game versus like your goal is to understand everything about the Clang compiler, these are like two divergent things. So my goal is to prototype games, and all I know is that I need to know what this -o is, or I need to like have that in there. I think it means make object files, but I don't actually know. So I'm okay with that. I right now presently know what I need to know. So let's kind of explain some of this other stuff, right? So building new solutions, undefined symbols for architecture x86, 64. Basically what this is saying is like, you referenced a function that we don't have the, we don't know where that is. We don't know where to find this. And that's because this actually is inside of a library that we use. So if we look at macOS main, we've imported AppKit in the source code, but in building the actual project, we have not we've not actually used that that framework. So we actually have to tell the build process. I think it is dash framework AppKit. Hope I'm right. Let's find that out. See what that does. Okay, so that gave us no errors in there, and for once I was right. Another thing too we can do is at the very end we can say finish building new solutions. Okay. Say okay, so we were building it and then we finished building it. But, and then that's just we would get the output. So if we do rsh build sh, you'll see building new solutions, finish building new solutions. And then if I do like a little, not there, actually, go from here. So now you will see that we've got some stuff in here. All right, we've got two files, and this is by the way, this is not where we actually want it to be. So this is inside of our Mac platform folder, and this is the dsym file. Basically, what that is, it's a dsym directory. Interesting. Oh, it's got a bunch of stuff in here. Okay, so this is all the like what this dsym folder / package bundle thingy does is if this is in the same folder that your application is in, and you run it in Xcode with a debugger, Xcode is going to know to hook up your application. It's going to know where to find the breakpoints and like how to step through your code with a debugger. So it's very important to have that. And then this here is the actual executable. So Move Solutions, there is the executable. You can go there in the Finder, obviously. So we can just go there and click around. So we're going to do that. I'm going to go to my app development, personal projects. Oh gosh, what is this? Video tutorials, indie game prototyping, build. No, just this is in the code directory because we didn't get this set up right. All right, so this is the same directory here. This is Moo Solutions, right? And then that's the dsym file. If I double click on it, I think what's going to happen is we're going to get, so if you follow my other tutorial, this is that code that was in our NS log, right? Remember that? Moo Solutions is running. Well, this is that same thing that is here. And the only reason I point that out is just to say, like, look, we actually built a program on our Macintosh computer, and it will output something to the console. So that's you know, we got it to work. Basically, is kind of what I'm saying. We made an executable using our own build process. So this would be a lot of like this is a little bit of an aside, but kind of like a lot of what I do when I make programs is I start with like just getting some bare bones thing kind of working. I guess this is what Casey refers to as compression-oriented programming. But like what I like to call it is just like I get the darn thing working, or like mostly doing what we want, and then later on we do all the cleanup crap, right? So we got this. We got like an application and we got it building and we can run it, and now we just need to like clean up after ourselves. Okay, well, what are some ways that we could clean up after ourselves after we got this working? Well, one thing we could do is that I think would make it, you know, kind of a lot nicer to live in this space. We could make it so that the output of the build process does not end up in our code directory. This is what I was talking about before. We want it so that the output of this build process goes into the build directory, so that code and the end product, or you know, it's kind of like if you're in a factory, like you don't want like, I don't know, like the candy boxes like all in everyone's crap like while they're walking around on the floor like trying to make the candy. You know, you want like there to be like a clear kind of process or a clear like assembly line of like, all right, the crap comes in here, you know, all the sugar comes in here, high fructose corn syrup or whatever, and then, you know, we dye the candy canes, and then at the very end somewhere else we have all the packaged candy canes. So we're trying to figure out how to get the packaged app goodness out of the factory, right? So they're basically like on any operating system, there's just like a lot of different ways that you could do that, right? So, and that is just depending on what, you know, if you watch Handmade Hero, Casey does this using the commands that are available on the Windows platform. Here we've got the commands that are available on the Mac using Bash. Bash, basically just Bash scripting. So what's interesting though is that actually the same commands on this like Unix-like environment are available. So I think Casey uses pushd and popd. So what pushd does, so we put pushd at the very beginning, right, of here. So I could say like pushd moves us into, you know, pushd moves us into a directory where we will execute commands. Execute. Okay. So that's what that does. And now, where do we want to go? Well, I think where we want to go is into the build directory. So in Unix systems, we want this to actually be like path independent. So we're going to do dot. So by that what I mean is like a relative path, which means that if somebody put this project on their computer, right, on their Macintosh computer, they would be able to run it without any additional setup. So that's the idea, is making it so that anybody who comes onto this project or joins your team or whatever can just run this thing and it will work on their computer without them having to do anything else. That's why we use relative file paths as opposed to absolute file paths. Because an absolute file path would only work on this machine. So what this means, so ... slash I think means, so and I actually have a tool kind of installed. I forget exactly what the tool is, but this tool will tell me, if I start typing these like file paths, it'll tell me where I can go. So in this case, if I hit ... slash, what ... slash does is it gets me like one directory up from inside of the Mac platform directory. So now I'm in the code directory. And if I type ... slash again, now I'm one directory up there. And so now I'm kind of in the main directory. And now what I can do is I can go build / Mac OS. And now what that does is this puts me in the Mac OS directory, right? Now, that's all well and good. So now this command, this clang command, the build command, I'm just going to say, yeah, so actually, so if I do pound here inside of a shell script, that's a comment, just so you know. I'll actually do this here. These are just comments inside of our shell script. So now you can say like clang will be invoked from inside of the build directory. Now that's actually really important, because what that means is that if clang is invoked, or if this compiler line that actually builds our project is invoked from inside of our build directory, what that means is the file paths are going to be different. So this is the output, this is the executable is still going to be the same, but the source code that we build the game from is going to be different. So that's actually going to be in a different place. Where is it going to be? Well, if you think about it, what we want to do now is we want to like go back out of the Mac OS directory, and then back out of the build directory, and then into the code directory, and then into the Mac platform directory. So it's a little bit convoluted, but I think it's something like this: ... slash slash code / Mac platform / Mac OS main. So that will then build there, okay? And then we're going to do pop D. All right. And now what pop D does, pop D actually gets us back to the directory where we started from, where we ran this command from. So it'll just get us back to the code / Mac platform directory, and as if we had done nothing. So as if we had gone nowhere. Push and pop are kind of this idea of a stack, which if you do like a lot of computer sciencey stuff, you'll probably understand that. Basically, like one of the things they teach you in computer science is there's this really kind of useful idea that of a stack, which is a way of organizing certain kinds of operations. It can come in handy in certain places. So if you imagine like I have a thing that I'm going to do, and then I like put another possible thing I might do, and put another possible thing on that, and then I can like unwind the stack, so take a thing off that, do it, take a thing off that, do it, on and on down. If you're not familiar with stacks in computer programming, go and read a thing about it or whatever. Maybe do a few like programming exercises about stacks. It's just general like good knowledge. A lot of how programs work is based on stacks as well, so good thing to know. So we're going to try and run this. First of all, I forget where we are. Are we still in that directory? We are. Just to prove to you that that the stuff is getting, well, actually, yeah, let's just go. I'll actually just get rid of this stuff from the Finder. So we'll go back to the Finder. I'm going to get rid of the things that we built earlier. So we're just going to move that to the trash. All right. So I'm just going to build this thing now. I'll run it. Oh, lovely. Okay. So now you can see that something's up. No such file or directory, .. slash code, Mac platform, Mac plat4. Okay, good. That's just a typo. I can fix that easily. That's not like, okay. All right, let's try that again. In Casey's video, he gets it wrong, but I was hoping I might get it right. That took a little bit longer. Okay, cool. So nothing too, I'm trying to look, yeah. So this will actually tell us which thing we changed to, I think. So I think what this is saying is we're here now, we were here, now we're here. So actually when you do push D and pop D, those commands must output what changed or where you went. So I think if you do push D, it tells you, yeah, so I think if you do push D, that command, it'll output to the terminal where you pushed to. And so that's that. And it does that kind of as an absolute path. And then it'll say, after that, it'll say like where you came from, which is, so we came from the Mac platform directory inside the code directory. And then we went to the build directory for Mac OS. And then when we pop D'd, when we pop the current working directory off of that stack of them, we ended up back inside of our Mac platform code directory. So that's cool. And now what we can do is just take a look and make sure that we weren't stepping all over ourselves. And then we actually did build an executable in the place we wanted to build it, which I believe is, yeah, so we're in build Mac OS. Yeah, and there you can see that we've got our stuff, right? So we've got Moose Solutions, and then we've got the Moose Solutions DSIM file. So that is all set up and well and good. And now, this is kind of just the start, because as it turns out, there's actually a lot more that is involved in the process of setting up a Mac application. So just doing something that like runs, you know, in a terminal or whatever, or just like, you know, you build it and you run it, that's kind of a lot different from, say, doing something where you where you've got like a full, you know, bundle application. So if I look at like my other game, the game prototype that I've been working on, this Cove Kid game. So the build is like, it's got all this crap, right? So like this is, so not only that, not only have I outputted like all this like stuff, I've actually got like a separate program. It's like a level editor and like all these other tools and things that I've used in order to make this game. I'm just kind of showing you where it ends up. But this package itself ends up being like a full application package. And if I right click to do show package contents, it's got all this stuff in there. So it's got, we're actually going to do this. We're going to make an info plist, and then we're going to like copy that in. So basically what we're doing is a lot of the stuff that if you do like an iPhone app project or something kind of using a default project template, we're doing a lot of the stuff that Apple would do for you automatically, right? And so, you know, and I also like to have these resources, directories. So this has the, you know, that's the app icon, and it's got all this stuff in it. I also have these other like different package files in here. So this has all my levels in it, and just a bunch of stuff. So I'm just saying this as kind of like you know, in the future it's actually going to be fairly involved. There's actually going to be a lot more to it. So that's kind of that part. Now, typically at this point, I would also be inclined, and because I'm kind of going a more traditionalist, or I don't know if it's traditionalist, but this is kind of more along the lines of what you would see in like a typical tutorial or a typical kind of video thing. We actually are going to use Git Source Control, you know, like it or not. And for this project, and now it doesn't work for all kinds of for like every project. A lot of other projects, say if you've got like really large binary assets, I wouldn't use Git. But I think just starting out, we can use Git and we'll be mostly fine. Especially for like prototyping, I think we'll be fine. So we're going to use Git Source Control. We're just gonna set that up. So the first thing I like to do is, if you don't have Git on your Mac, you need to actually download the Git command line tools. So that's going to be a really important thing. I pretty much only use Git from the command line. I really don't like using it from like an application that you download, and there's a lot of reasons for that. Like the main reason is what I find with the applications, like the Git applications, is they create this like extra layer of abstraction between you and the actual Git commands that doesn't really it doesn't map one-to-one to what the actual commands are. So this like abstraction layer like tries to pretend that Git acts in a way that is different from the way that it really is, or from the command line interface. So like how the commands are actually set up and structured. And so you're led to believe that Git source control works a certain kind of a way, and you have this kind of like false picture in your head, or this false abstraction or false idea of how it works, when in reality it actually works a completely different way. And the command line way of working with Git is more like how it actually works. And so you have a more accurate picture in your head when you use the tool. And so if generally speaking, if you have a more accurate picture of how things actually work, when you go and use them, I think, more likely to use them better. So that's sort of like my reasoning for now. If that tool, if the UI tool or whatever, like if the way that it presented how Git works were more in line with how it actually works, I don't think I'd have an issue with it. It's just that it like creates this kind of fantasy that I don't like. So that's like why I don't use it. So the first thing we would do is we need to like go into the actual root directory for the project. And so I just do cd $video tutorial, right? And then the first thing I do is I just run a git init command. So r ! git init. And what that does, so I get some feedback from that. It just says initialize an empty Git repository. Okay, great. Then the next thing that I do is I go into GitHub, and nope, we're doing this later. Not interested. All right, so the next thing I do is I'm going to create a new repository, and this is actually going to be public because I just want to share it. I don't know. Indie game prototyping videos. I'm going to call it that. I'm going to call it a project for indie game prototyping that you can follow along on YouTube. All right, so we're just going to make that. And it's a public one because I don't mind if people use it. There's really nothing in there. I don't use any of this stuff yet. We will do a git ignore, but kind of later. You'll see what that is. A git ignore is kind of, so README file, like I don't like to do any of that crap until like I've actually got people collaborating with me, because otherwise what's the point? License, I guess we'll choose a license. What do we want? Oh my God. I think we want the MIT license. Jeez. Talk about tons of options. So we're just going to create this. All right, so what does this do? Well, what this does is it creates like an empty repository on GitHub that's like a remote one. So one of the like really, if you use Git source control, one of the really important things to know is the difference between like the local and the remote. And this is yet another reason why I don't like to use the Git application or the client application, is because it sort of muddies this idea of that there is a remote, right? It like makes it seem like, oh, you're just syncing files, and it creates this kind of pretend world. So basically what Git has is it's got the remote version of your repository, and then it's got the local version of your repository. And different computers are going to have different versions of the local repository on their actual machine. So they're going to have different content from the so a lot of what you can do is you can actually pull down specific pieces of code or specific versions of your code at one point in time from the remote, and then you can keep that on your local. And then it's kind of up to you on your local computer to decide what parts of your local code you want to then propagate back up to the remote. Probably a terrible way of describing it, but that's as good as I can. So they give you a few of these commands here. I'm also not going to go over the details of how to set up Git to work from the shell, just because it's kind of, I've already done it on this computer, and I don't really want to go too much into Git source control. But I prefer to use it from the SSH terminal, and I prefer to just like set up an account and have all that taken care of that way. I find it's a lot easier than doing it over HTTP. So we're certainly gonna, so we have a few options here. Create a new repository on the command line. We're not doing that because we already have done that, right? And some of this stuff is it's like already giving us, you know, some instructions here. We don't really need to do that. So what we can do though is we can push, yeah, so you notice that this line here is basically the same. So we're going to keep this one. So we're going to do that, and we're going to, so remember, all I'm doing is I'm taking that R exclamation point, and then I'm going to run the Git commands from there. And so now what that's going to do is, now I can check, so I believe that command is run really quickly. You can do git remote -v, and all that does is it tells you what is your remote now. So that's good. Now the very first thing I'm going to do is just run a status check on Git. Okay, so this is useful. One thing too right now that's they really strongly encourage you to do is they strongly encourage you to, yeah, so they strongly encourage you to use the name main right now. For whatever reason, I don't want to go into it, it's like stupid politics crap. But basically, like, you're just going to be fighting with it if you don't change your branch, your master branch, to main. So that's one of the first things I usually do nowadays. So the first thing I do is I go R exclamation point git branch -m main. Wait. Master not found. Is it -big M? Huh. We'll figure this out, I'm sure. All right, well, first thing we'll do is we'll add a document. We'll add, so what this does is it adds all of the current files into this initial commit, or the initial like batch of code that we're putting up. And then we're going to do an initial commit. So a git commit -m. All that the lowercase m means is give it a message. We'll call it initial commit. So now we created all of this stuff on this branch. Maybe now we can do this. Did that work? Okay. I guess I just had to have a commit. So now it says on branch main. Okay, great. So that's git branch -m, which will rename it. So now we've renamed the branch. We're on branch main. We've done our initial commit for the project. And then now the first thing I would want to do is I would do r-git push -u origin head. Now this is going to sound like a lot of fancy gobbledygook, But basically what this does is it takes the local version of our code that we have here, this local original commit for the project, and then it pushes it to the remote server as the current branch that we're on. Head, I think, is just like the most recent. Again, not going too much into this, but head is just like the most recent place where you are in terms of the commits. One way to think of Git source control is it's like a commit is basically just like a chunk of code that was changed, and what you're doing is you're building like this kind of like commits on top of commits on top of commits. So I have a commit there, and then I put one on top, and then put another one. Head is basically like the latest commit. It's a way of thinking about it. So that didn't work for whatever reason. The remote contains work that you do not have locally. Okay, so first thing we need to do, annoying. Git fetch p. Git pull. So fetch just gets stuff from the current branch that you're on. Pull then like grabs those changes. I thought I did this already. Ugh. This is what happens when I'm working on things. I've got a better idea. Wait. Target. So push, set upstream, origin, name. Let's see that. Oh! Hang on. Rejected. I tried to do that and that didn't work. Pulling. This is kind of why I don't like Git source control. There is no tracking. Specify which branch you want to merge with. What? You wish to set tracking information branch. All right, let's see what this did. Hang on. Oh, of course, because this stupid one has the license on it. Ugh. That sucks. I don't like. I should have just like not. I usually don't do this with the license. I shouldn't have done it with the license because that actually changes things. That sucks. What should we do? Oh yeah, so this is that commit. All right. Annoying. Very, very annoying. Can we do a force push? No, I think I already tried that. Did that work? Huh. Awesome. All right, so what I just did there was something that you're told not to do. Typically, I took our current branch because like I know that I want the branch that we're on, the main branch. Hang on, let's get that command back up. So if you can see down here, it says R exclamation point git push -u -f origin main. So this is the same as that set upstream origin, which basically what that's doing is saying like take the current branch that you're on, and when communicating with the remote GitHub server, use the main branch as the one, have that track or have that one track changes with the remote. And then the -f is like, I don't care what's currently up there in that branch right now, we're just going to overwrite it. So it's like a force push. So if you're really, really darn sure that the thing that that you have on your branch right now is what you want to be there up on the remote, then you use the -f. One of the things, I'm almost certain this is going to happen, so I'm just going to like go look at it. Well, I am very sure, actually. What's going on here? Come on. If we refresh this, we're not going to have a license. Yeah, exactly. So we don't have a license anymore because I replaced it with our code. So this is what we've got here. So we've got code / Mac platform, and yeah. So this is our code. This is our project. It's available on GitHub. Now, one thing I like to do as well, or one thing that I'm going to do specifically for this project, is I'm going to create branches for at the end of each day. And what that's going to allow you to do is it's going to make it so that you can follow along just by going to the repository and then going to that day, and there's the code, right? So I'll just do like one of the commands you can do in Git. We'll be using Git Source Control a lot, so don't worry too much if you don't understand what a lot of this is. I'm just kind of showing you how I do it so that you can play around with it. The real learning process for you, for learning Git and all this stuff, is for you to go and then play around with it yourself. I'm just showing you what I do. So I'm going to do r ! Git checkout -b. And what B does is that just creates a new branch, okay? So it's going to be a new branch with whatever name. I'm just going to do something just day-002, because day 2 is actually what this is. This is day 2. So we're going to do that. And now you'll see that we get an output from that command, switch to branch day 2. And then all we're going to do is we're just going to push the current main branch or the current code. So whenever you do a branch, like let's say that Git is like, the tree is like, this is main. So we just put like one commit there with like the initial code. And now we're doing a branch just for day 1, right? And the code is actually for day 1 and main right now is going to be the same. But let's say tomorrow, then what we're going to do is we're going to go back to main, we're going to work on some code, right? And then we're going to make another branch for day 2, just so you can access it, right? So you can think of actually these branches are just like, they're kind of like folders with the end result of the code at the end of that day that we worked on it. That's all that is. So don't overcomplicate it. I know like some people get into like all this crazy complicated, branches inside of branches, a release branch that goes back to the like hotfix branch, and then the hotfix branch goes to the hotdish branch, and like we're not going to do any of that. We're actually just going to, because we don't really need to. We're not actually on a team with like a lot of people. It's just me here. So we're just going to have like the main branch, and then we're going to have like individual branches at the end of each day, just so you can follow along. That's all we're doing. So we're just going to that same command r git push -u origin head. Okay, and all that does, if we take a look and go back to GitHub, what that's going to do is I'll refresh this, and you'll see that now we've got 2 branches, and then we can look at our branches, and then we've got day 2 is the branch that we just created. So day 2 is going to have all the source code at the end of day 2, right? And then main is just going to be kind of wherever the project happens to be. But this is just for you folks who want to follow along specifically at the end of the day, and you want to make sure that you have like the exact same code that I have. So there you go. I think with that said, like this is a pretty good place to stop. I don't want to go into, I think if we started another thing, it would just kind of like, it would be another thing, and it would sort of be a long time. So I don't want to do that. I think we'll just stop here. And if any of you have, since this actually isn't, the only reason that I'm not doing this as a live stream right now is because our internet is like really, really crappy. We live out in rural Virginia. And so that just means, and like we're using like CenturyLink of all things, which like sucks. So I don't even want to try live streaming. I can barely upload the videos as is. But I'm just saying that because I do want to do a live stream. It's just, I think we have to wait like a year for like fiber to come here or something. It's going to take a while for like better internet to get here. So I'm just doing videos. which is, and I'm leaving the comments open, which I'm sure are going to be filled with all kinds of like rational debate and nothing inflammatory. But in those comments, you know, you can ask questions, and you can, whatever you ask, I'll try and make sure that I take some time on the next video to address some stuff that you asked. So, with that said, I shall conclude. And thanks for watching. Click all the links at the bottom if you're interested in some of the other stuff that I'm up to. Obviously, support this on Patreon if you're so inclined. Whatever you can do, I really appreciate it.